Hi, hello everyone. Welcome back to Deep Learning video lecture series. And this is Dr. Chiranjeevi Manike, Professor in Data Science and Cybersecurity Department, MLR Institute of Technology, Hyderabad. So in this lecture, we are going to discuss mainly the hyperparameter tuning. This is one of the important topic in machine learning and also the deep learning. So in this lecture, I'm going to explain mainly the difference between the parameter and also called as a model parameters and a hyperparameter, one of the main concept. And then we'll see what is hyperparameter tuning and how does this hyperparameter tuning works, and also we'll discuss how to select hyperparameters, and then what are the hyperparameter tuning techniques and the end we will see the differences between these two. So let us try to understand what is difference between the parameters and the hyperparameters. So it's a very simple concept, but it's a very important one. So in deep learning, parameters are the model parameter, also called as a model parameters, are the learned values within the model itself, like weights and biases in the neural networks. So these weights and biases are adjusted during the training, that is to minimize the loss function, because we have to find out the model trains and it will predict, and then we'll compare with the actual values and we'll find out the difference, that is with the help of a cost function, loss function, and then the loss need to be minimized. So accordingly we will adjust this weights and that is a model will automatically adjust the weights and biases. So these are the few parameters, are the model parameters, and these parameters are the variables so that define the model's structure and how it maps, because the model, building the model means it has to identify the relationship between input and output. Input would contain the features and then output. So it has to identify the exact relationship, or the model will have to capture the underlying patterns. So these parameters are learned from the data during the training using optimization algorithms like a gradient descent. And whereas hyperparameters, so hyperparameters on the other hand are the settings that control the training process and are typically set before training begins. So here these are some examples of common hyperparameters. We have already discussed in the previous lectures what are all these parameters. So in coming lecture I will show the one code also, that is to understand how we can tune these parameters. So then how the model performance changes accordingly. So here if you take the examples of hyperparameters, so learning rate is a one hyperparameter that is mainly used, that is at what rate an algorithm updates the estimates, and then learning rate decay, that is a gradual reduction in the learning rate over the time to speed up the learning process. Then momentum, that is in the direction of what is in which direction the next step, that is with respect to the previous step. And the neural network nodes, mainly that refers to the number of nodes in each hidden layer, etc. And few other hyperparameters are neural network layers. These layers refer to the number of hidden layers in the neural network, and also the mini batch size, that is training the batch size in epochs. So is the number of times the entire training data set is shown to the network during training. And then eta is a step size shrinkage to prevent overfitting. Next, if you look in detail, like mainly if you would divide the parameters and the hyperparameters, and again the hyperparameters in deep learning models. So mainly the weights and biases. Weights, that is to connect, these are the connection strengths between the neurons. And the biases, these are added to the weighted sum before activation function. And if you check in the convolutional neural networks, that is CNNs, filter are the kernel weights, biases for each filter. Whereas in recurrent neural networks, the parameters are input weights, recurrent weights, and biases. And if you look at the hyperparameters mainly, because these hyperparameters are depends on the model, training related and data related, etc. So let us see one by one, just it's a quick recap. So model related hyperparameters are like a number of hidden layers, as we already discussed, and the number of neurons per layer, and the activation functions, because activation functions play significant role in deep learning, like a ReLU, sigmoid, TANH, and softmax, etc. Then the type of model, like CNN, convolutional, recurrent neural networks, and also the transformers, etc. Next, training related hyperparameters like learning rate. So batch size, number of epochs, optimizer type like stochastic gradient descent, ADAM, etc. And also the loss functions like cross entropy and MSE, etc. Next, other hyperparameters are regularization hyperparameters like a dropout rate. Previous lecture I already explained, like few the percentage of nodes will be dropped, and also the L1 L2 regularization strength. Next, the data related hyperparameters. So the data augmentation techniques, train validation, test, split, shuffle, or not before training. So these are the hyperparameters used in different types of hyperparameters used in models. Now let us, so far we discussed what is the difference between the parameter and hyperparameters. So next, what we have to understand, what do you mean by this hyperparameter tuning. So here whatever we discussed so far, like parameters, these are all a kind of variables. So these are only used to determine through the multiple experiments. We don't have any rule, like a set of rules or a formulas that is to decide. So we have to do the multiple experiments, and we have to pick a set of hyperparameters. Once we done the experiments, then we'll set we pick a set of hyperparameters and run them through our model. Next, training our model sequentially with the different sets of hyperparameters. If you take, to understand why is the hyperparameter tuning is important, if you take one example, suppose if you are using the learning rate of the model as a hyperparameter, here you can see from this diagram, like here where the learning rate is too low, and this is a right learning rate, and this is a high learning rate. So if the learning rate is too high, so that is this figure, this plot you can see here, the learning rate is high. So that means this model may converge too quickly with a suboptimal results. So whereas if the learning rate is too low, and this one left side image, too low, that means the training takes too long and the results may not converge. Next, the best one is, or the balanced one is, that is the results in inaccurate models, accurate models, and excellent model performance. Okay, so here you can see here the model has converged, whereas in this case where the learning rate is high, it is not converged, right? And here whereas where the learning rate is very low, also it's very, it takes a long and the results may not converge. So that's why the hyperparameter tuning is a very, very important one in deep learning and machine learning. So Next, how do we identify the hyperparameters? So selecting the right set of hyperparameters is a very important in terms of model performance and accuracy. Like suppose if you have defined the loss function, our objective is to minimize the loss function. So the more the less the difference or the loss, the more the model accuracy or the performance would be. So there are no set rules. It is unfortunately on which hyperparameter work best, nor their optimal or the default values. So you need to experiment to find the optimal hyperparameter set. So that's why this is also called as a hyperparameter optimization. Next, how does hyperparameter tuning works? So it can be done manually or it can be done using automatic, like by using the automated techniques we can do this hyperparameter tuning. But if you do this hyperparameter tuning manually, then it would become very slow. But here the advantage with this is we understand how the hyperparameter weightings affect the model. Next, here how does this hyperparameter tuning works? Mainly this is a process of hyperparameter tuning is a iterative. Okay, it is a iterative process and you try out different combinations of parameters and values. So you can generally start by defining a target variable such as accuracy as the primary metric, and you intend to maximize or minimize this variable. So it's a good idea to use mainly cross validation techniques. So your model is not centered on a single portion of your data. Like suppose you can see here from this diagram, and this is one data set. So to train the model, we'll divide the data set into like let us say like 20% of for testing and then 80% for training. Okay, if you have done this, like just simply splitting the data set into 20% and 30, that is a training and testing only once, and if you train the model. And similarly in another way, like suppose if you use the cross validation, so here this is a 4-fold cross validation. Like here you can see here the data set is divided into the 4 parts. You can see 1, 2, 3, 4, right? So these are the 4 parts. We have divided the data set into the 4 parts. So now first let us say the first time fold 1, like we have and this is the testing set we used, and the remaining part is used as a training. Okay, so then we have trained the model. Next fold, we'll take the another part of the data as a testing set, and the remaining part is a remaining portion of the data set would be considered as a training. So then again we'll train the model, and similarly, and we'll take the another part as a testing and the remaining part as a training. Like here you can see here, if you observe this like a 4-fold cross validation technique, we have divided this entire data set into the 4 parts. So each time, so we are using the different testing set and different training set. So that means we are allowing the model, that is to so we are training the model on the not just on fixed training set or testing set, so that it will be more generalized. So we can find out the average value, so then that would be more closer to the real world values, or its performance would be more, accuracy would be more. Next, what are the hyperparameter tuning techniques? So there are numerous hyperparameter tuning techniques, but most popular and most frequently used hyperparameter tuning techniques are Bayesian optimization, grid search, and random search. So let us see one by one. So Bayesian optimization is one of the hyperparameter tuning technique. It is mainly based on the Bayes theorem, so which describes the probability of an event occurring related to the current knowledge. So when this is applied to the hyperparameter optimization, so the algorithm builds a probabilistic model from a set of hyperparameters. So that optimizes the specific metric. So it uses the regression analysis to iteratively choose the best set of hyperparameters. And the grid search and the random search. So from this, by seeing these images, you can easily understand what do you mean by this grid search and random search. So let us try to understand the grid search so that you can easily understand the random search. So here you can see the grid, like suppose if you take along this one, the parameter hyperparameter 1, hyperparameter 2. And then there are many possible combinations we can take against this hyperparameter 1 and hyperparameter 2. So we can systematically, like suppose let us take this value and this value like this. We can do the experiments, we can train the model and we'll measure the accuracies. So grid search works well, but it is relatively tedious and computationally intensive because when the large number of hyperparameters and the grid, the size of, or we can say it's like a search space. I can't say it's a search space. The grid becomes large, so then there will be many. We need to conduct many experiments. So that's why it's computationally intensive. But whereas the random search, no need to select, no need to use the all possible values in sequential. You can randomly select the combination like the hyperparameter 1 and hyperparameter 2. So then we can train the model. So this is the way we use the hyperparameter tuning techniques. So let us quickly recall what we had discussed in this lecture. So here in this lecture we discussed about hyperparameter tuning. So it is the practice of identifying and selecting the optimal hyperparameters for use in training the machine learning models and also the deep learning models. So when this the hyperparameter tuning is performed correctly, the hyperparameter tuning minimizes the loss function. Like the best set of hyperparameters are, once you identify the best set of hyperparameters, so those hyperparameters minimizes the loss function of our model. So which means that the model performance is trained to be as accurate as possible. So parameters, as we discussed the parameters, also called as the model parameters and the hyperparameters. So parameters are learned, whereas the hyperparameters are set. So parameters define the model, while the hyperparameters control the learning process. If you could summarize the differences between these two categories, parameters and hyperparameters, and based on the categories like learned during the training, set by the developer, and changed during the training, stored in model file. Like because if you take Amazon, AWS, so they have a SageMaker like the automatic, like it will take care of finding the best parameters. That is a hyperparameter tuning is done by the SageMaker framework. So now let us understand the differences mainly. Like suppose if a data scientist involves and he is going to have the control on this two varieties of parameters like parameters and hyperparameters. So the learned during the training process. So the parameters are learned during the training process, whereas hyperparameters are not learned because these are set by the framework, or set by the developer, or set by the data scientist, or set by the ML engineers. Next, set by developer. So these parameters are not set by the developers because machine learning learns itself by tuning the parameters. That is adjusting the parameters to find the exact correlation or the near correlation between the input features and the output of the target. So this hyperparameter is set by the developer. So changes during training. So here we can do the changes in terms of parameters, but whereas hyperparameters cannot be changed during the training. Next, where these parameters are stored in file. So here the parameters are stored in a model file, whereas hyperparameters are not stored in a model file. So thank you for watching this video.